Alright, this is a video to help out with, in chapter 10, section 10.2, we're working on the regression line. And in the past with this class, I've used just the graphing calculator, and we've made the move over to using the internet and some different websites. And so this is a video to assist with using easycalculation.com to be able to find a regression line for a statistical plot. Alright, so as you see, there's going to be two parts to your directions here. You've got section 10.2 regression with the graphing calculator, and then you have section 10.2 with easy calculation. And so let's kind of just jump right into this. So here's the problem that we're given. This is example number 13. So we're given this data set. We actually did the same thing with this data set in section 10.1, and we made a scatter plot. And so we've already seen a video on how to make a scatter plot on easy calculation. And recall, we found that line of regression, and that line of regression was this line. I'll just adjust a few things real quick. Was this line, it's kind of like the line of best fit. So it's this line that fits kind of all the data points, and maybe we would move that up a little bit, maybe like that, or something along these lines. So kind of say, okay, maybe right there. Well, we want to know the exact line. We want to know the exact line of regression. So I'm just going to move to another slide real quickly and kind of show you. So when we find the line of best fit, it's this idea that we're trying to find the line that fits all of the data points best. The way that is found is through this observed value versus a predicted value. And we use those observed versus predict values to find kind of like an average or a middle place. And here's the formula they basically go through. So they're going through this whole, change in y, change in x kind of deal to calculate this. So when we come back to that, what we see here is we see this nasty little formula that can be done by hand, which basically comes down to the situation of where for every data point in this list, you would have to plug them into this little formula here. And you have to find the differences, find the change, and go through this calculation. And once you did that, you would get your A value. And your A value in this case represents where you cross the y-axis. So the A is basically your y-intercept, and your B value in this formula is your slope of your line. So as we use easy calculation to be able to find this line of best fit, or regression line is what we call it, keep in mind that A value that we find is going to be our y-intercept, and the B will be your slope. So let's go ahead and go to the website and kind of see how it looks when we go there. So here we are, and so this is the link that I'll provide you in the homework assignment. And you come here to easy calculation. You scroll on the screen a little bit. So come regression calculator. Scroll down, and we start entering our data values. So our first data value is for number 13 was 361 and 3844. Add more. Go to the next data value, 270, 1962. Add more, 306. So remember that the number of releases is your the number of releases is your X value, and the gross receipts is your Y value. So now here we are. So we're, click in there. So we got 306, 1371. Add, we'll do one more, so you don't have to sit here and watch me do the whole thing. 22 and 1064. So you go through the process, you keep on moving through, and what happens is it ends up giving us a regression line, or a set of data that looks like this right here. So once I get them all entered in, you hit calculate. That calculate will then kick out, tell you, okay, you had 9 total numbers in your list. Out of those 9 numbers, your B value, your slope, remember from the previous screen, so that gives you, like I said, 9 numbers there. It gives us our slope. So if we recall from the previous slide just a moment ago, we said that our B value, that had the wrong thing. We said that our B value would be equal to 2.40109, which for the sake of conversation, we can go ahead and say, they say round to 3 decimal places in the book. So if we use 3 decimal places, we do 2.401. Our A value is, or our Y-intercept is 355.541 because of the rounding, because the 5 right here will round the 0 up to a 1. So at that point, you can see how they place that into our regression line. So essentially what this is saying is we can look at this equation and say, okay, our y-intercept is 355, and we have a slope of up 1, up 2, and, not up 2, but yeah, up 2 over 1, or up 2.4 and over 1. Because remember, slope is equal to rise over run. So, in a situation like this, essentially what we're looking at is, so 355, so maybe maybe that's 7, that's 250, so 355, about right there, maybe, approximately, right? And then from there, we're going to kind of try to find this line of best fit. So, I don't really know for sure. I don't really know for sure, like, what up 2 and over 4 is because the numbers are so big, but it just gives us an idea to see a line of fit, or a linear regression line, and kind of get an idea of what, if we did create an equation for this, what would the predictable equation be? So with that said, now that we have this scenario where we've talked about, in this case right here, a new movie released per studio and gross receipts. So come back to this little table that we had a moment ago. Oops. There we go. So remember, X was the new movie releases, the number of releases, and then the gross receipts is the Y value. So this is the number of new movies released. This is the gross value in millions of dollars. That's per studio. So if there's 361 studios releasing a movie, then there's $270 million. And so we have these data numbers that we can go off at this point, and so we can make a prediction. So if we wanted to find out, for example, now, I don't know, let's say that maybe what would happen if there was 100 number of releases. So if all of a sudden we said, okay, well, we want to find out what happens when X is equal to 100, now we can take our equation of best fit, which is 355.541 plus 2.401 times 100, because X is our 100, and we can go ahead and multiply that through, and we can find a prediction. We can actually find out a predicted value for what's going to happen with our gross movie receipts. So that predicted value in this case would be 595.641 millions of dollars. Okay, so $595 million would be the predictive, or the outcome of that prediction. So, and that, like I said, that one more time would be is if you had to make a prediction on a problem based upon your linear regression. All right, so this is section 10.2. This is actually number 13 that I completed for you. And so you'll use this in conjunction. This is if you're using easy calculation versus the TI 83 and 84. Let me know if you have any questions. Thank you.